Okay, let's work on number 18, 19, and 20. A researcher wants to know if taking increasing amounts of ginkgo biloba will result in increased capacities of memory ability for different students. He administers it to the students in doses of 250, 500, and 1,000 milligrams. What is the explanatory variable in this study? Hopefully at this point you guys are skilled in recognizing what explanatory and response variables are. The explanatory variable, again, is the independent variable, and it's in the x-axis, and it's the things that you can change. And the response variable is the dependent variable. They just respond to the different changes we make on the explanatory variable. So it's clear here that we are administering different milligrams of ginkgo biloba to students. So it's pretty straightforward right there that the ginkgo biloba is the explanatory variable, and what the response for that is the increased capacity or the change in memory ability for different students, right? So letter C is the answer because it's not the size of student's brain. It's not whether the student takes the ginkgo biloba. It is what we're changing is the amount, and what is independent is the amount of ginkgo biloba given to each student. And then the response is change in memory ability. So if the question is what is the response, then it would be D, but 18 is C. So hopefully you're really, really good right now, or at this point, in recognizing what the explanatory and response variables are. So for number 19, the graph to the right shows the linear relationship between diamond size and price for diamond size, 0.35 carats or less. Using the relationship to predict the price of a diamond that is 1 carat is considered. So 1 carat, if my range is from almost no carat to 0.35, my 1 carat is like here or further out, if you follow my mouse. And if it's this far, if it's way outside our range of data, we know from definition from I think chapter 5 that that's an extrapolation, and we don't do that because we don't know what happens to this line after 0.35. It could straighten out like this, or it could skyrocket up. So when we do something like that, when we predict outside our range, it's called an extrapolation. So for 19, the answer is A. And then for 20, it says using data on the appraised value of homes, a real estate agent computes the least squared regression line for predicting a home's value in 2002 from its value in 1992. The equation of the least squared regression line is y is equal to 22,000 plus 1.6x. All right, let me just illustrate what this least squared regression line is saying. So the value in 1992 is our x, and the value in 2002 is our y. So if we have a home and we plug in, and this is a predicted, I'm just drawing it so it makes better sense to you. I don't really even have points. I just drew what the line could be, and it's a positive linear line because of my slope is 1.6, right? So if I plug in a value in 1992, I should be able to predict the value in 2002 what it would be. So if my value of my home is 500,000, I should predict that it's this is the value right here. So knowing that relationship between, or how this line operates, basically, let's read which of the following is true of the least squared regression line. So the slope is the change in a home's value in 2002 that would be predicted by a dollar increase in a home's value in 1992. So again, going back to our figure, 1.6 is the change for every dollar amount X that you put in, because that's the value that you're putting in 1992. So it increases by 1.6 plus 22,000. So A is correct. Sorry, let's go with A. A is true. So this could be a case where it's D, right? Because if that's true, then see if B is true also. It always passes through the point X bar, Y bar, the means of the values of homes that were used to compute the least squared regression line in 1992 and 2003 respectively. That's true. Your least squared regression line always has to pass through X bar, Y bar. And C, it will only pass through all data points if R is equal to positive or negative 1. And that's also true because if every single point passes through the line, then it's a complete straight line. So I hope that's clear. It will only pass through all the data points if R is equal to plus or minus 1. Yep, that's very true. So the answer is D. It's all of the above. So that's 18, 19, and 20. And that's pretty much all of the multiple choice for this practice exam 1. If you have more questions, come to the math lab and they can clarify some of the things that I wasn't able to talk about in the videos. But I hope you do well in the exam. Good luck.